Alright, for section 3.4 grade 7s, we're going to deal with the area of a parallelogram. And so we're going to determine the area of a parallelogram, and we have a formula to do that. And that formula is that the area of a parallelogram is equal to its base, which, if this is your parallelogram, the base is the length of your flat side, times your height. Now, the height is not the length of the diagonal side. The height is the actual height, which will be given as a separate measurement, hopefully, when you're dealing with this. So, this is your base, and your height is perpendicular to that base, so at 90 degrees, not at an angle. That's the one key here to remember. And you might be thinking, well, that looks an awful lot like the equation of the area of a rectangle, base times height. You're absolutely correct if you recognize that. Here is a parallelogram on some graph paper. If you notice that if you work straight up from this corner, it forms a triangle, which is exactly half of the area of this rectangle here. Well, the piece that's missing can actually be found on the other end, because there's another triangle here that takes up exactly half of this rectangle, and those triangles are the same size. So if you were to cut the tip off of this so that this was a nice square rectangular end, you could put it over here and it would form another rectangular end. So the base times the height, that's how this works. It works for a rectangle and it works for a parallelogram. As long as you're using the correct height, it will work. So, for example, in this picture, if our base is 5 centimeters and our height is 3 centimeters, then we know that 5 times 3 is 15. And when you're dealing with area, you need to remember to use your units. And since we multiplied centimeters times centimeters, that actually becomes centimeters squared. So when you're dealing with area, your units are going to have a 2 here that's going to be squared. So you do need to remember that. And I will be looking to make sure that you have your units when it's applicable. So another approach here is you can do a check using estimating by counting your squares. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 that are full squares that are inside this parallelogram. We've got 2 that are almost full. There's one there and one there. I got 2 that looks like it's pretty close to half right here. So 2 halves make a whole. And then there's just a tiny bit left over here on these 2 little pieces. So 12 full ones plus 2 that are about half, or sorry, 2 that are almost full, plus the 1 that these 2 halves make up. If you add that up, that actually does equal 15. So if you happen to have a parallelogram that's drawn to scale and on a grid, you can actually count the area and get pretty close. And in this case, the 15 is accurate. Anyway, next up is a show you know. So try and calculate the area of this parallelogram using the formula.